Okay, let's continue on with chapter 2 and talk about the importance of water. So before we even start on the next slide, what is the big characteristic that we've been talking about that links to these characteristics of water that we will be discussing? And it's the fact that water molecules, right, so the H2O molecules themselves can form hydrogen bonds with other H2O molecules. So let's move on and kind of see because of these bondings, how does this contribute to water's characteristic? So again, just to recap, water is a really important molecule on the earth because we're made mainly of water, right? We're like a high percentage of our body is made of water. The planet is covered in water, and water has these unique properties that helps it sustain life. And so if you recall, water is a polar covalent molecule, meaning that the electrons between hydrogen and oxygen are actually shared, but they're not shared equally, right? That's one of the things that we mentioned in the previous section is that polar covalent bonds, if there's polar, they're not shared equally. So you could think of this guy, this oxygen, as more greedy when it comes to the electrons, and so it's slightly negative. And so, as we mentioned as an example before, we have two kids and they're both playing with toys. They're both holding on to toys, so they're both sharing. They're sharing a toy, right? But the one kid is grasping it a lot stronger. One kid's really grabbing it. It's almost at his chest, like he's really pulling it. So while they're sharing the toy, that kid is more greedy, so the toy spends more time in that kid's radius, right? Whereas the other kid is still holding onto it. Maybe he has his whole hand stretched out and he's holding onto the toy and he's like trying to grab it, but he's stretched out. So the toy is spending less time around his body, because it's more stretched out and closer to the other kid. So this guy is partially positive and why is it negative and positive? Because electrons are negative. And so because the oxygen has the electron closer to itself, it's almost as if it has the electron counting as part of its orbit, and so it's more negative compared to the hydrogen. And so this results, because of that polarity, this results in water being a really good solvent. So think about how when you put salt or even sugar into water, how it can dissolve. It has a lot of cohesion and adhesion. So think about how, water, as I'm going to grab my cup of tea, right? Or my cup of lemon water. So this is water and it's cohesive. Like if I move it, I can see the whole water, especially in the top, moving together. But I can also, I'm not going to do it. I can also go in here and reach and grab water, right? And make droplets. So it actually, they're not like solidly combined together like the way you expect the glass right here. This glass mason jar is actually solid. So water has a cohesiveness to it. And if you can tell that water also has a high surface tension, right? You've seen those water spiders that can actually straddle on top of the water because of that surface tension. It also has a high heat capacity and heat evaporation because it takes a lot of energy to break those actual bonds apart. And it has varying density depending on if it's a gas or if it's solid or if it's a liquid. Another thing that's really interesting about water is the fact that it can exist in all three states. It can exist as all three states of matter, right? It can exist as a solid, liquid, or gas. Okay, so next slide. So water, as I mentioned, is a really good solvent. And so a lot of molecules are able to dissolve easily in water. So when the solid is dissolving, water will cluster around the different ions and keep them separate. So recall our salt example that we said that once sodium donated its electron. So if you remember previously, we talked about how the sodium it had that extra lone electron that was on this shell. I'll draw real quick. That was on this shell. And with chlorine, if you recall, it was sad because it didn't have a full valence electron shell. So when this sodium donated its electron to the chlorine atom, it was happy because now it had a full valence electron shell. And this sodium, because it lost that electron, it went down to next valence shell, and that valence shell was also became a full valence shell. So both of them are happy now because they're stable. But because that electron shift and moving, it made it so the sodium, because it had one less electron, it became positive, whereas the chlorine atom, because it gained that electron relative to the number of protons it had inside its nucleus, it is now negative. Right? So if this is positive, negative, what do you think is going to happen? Well, water molecules are partially negative and positive because of that polarity, that electronegative. So all these negative oxygen is going to kind of want to be near the sodium. So they kind of all gather around the sodium. And the same thing happens over here, but with hydrogen. All of these hydrogen atoms that are positive, partial positive charge, will surround itself with this negative charge right here. And so they're kind of surrounding chlorine. So they kind of separate the sodium from the chlorine, and so that the sodium and chlorine are dissociating from each other because of the water interacting together. And that's the reason why you have water being able to be a solvent, so dissolving these solids together, so that you end up with the sodium and the chlorine kind of separating and dissolving, right? And just to if molecules are actually attracted to water, like sodium chloride here, they are hydrophilic, so they like water. Philic is loving, right? So they like water, so they're hydrophilic. However, if something that does not dissolve very well, is not attracted to water because of this polarity, so things that are not polar, that are non-polar, they don't dissolve in water. They don't enjoy being in water the same way. And those are considered hydrophobic. So phobic because they do not enjoy water. So can you guys think of an example of something that we mix in that's not attracted to water? Think of your salad dressing, right? Vinegar is pretty much water, right? So vinegar is a water base, is what I should say. It's water base. And when we actually add a little bit of olive oil to it to try to make a vinaigrette, the olive oil doesn't mix well with the vinegar, with that water base, because the olive oil is non-polar and is hydrophobic. It does not attracted to water. So you have to kind of really shake it up, and to order for to make a salad. But if you let it sit there and rest, it will eventually separate again, right? So we've all observed that. Okay, so hydrophilic, hydrophobic. So let's talk about some of the other characteristics, and this would be cohesion and adhesion and high surface tension. So these are all characteristic of water. So hydrogen molecules that hold molecules in liquid together have high surface tension, right? And I mentioned before, because water has that high surface tension, because they're kind of binding each other, because they form these hydrogen bonds together, they're kind of forming like a nice layer, and that attraction results in water having this nice surface tension. And that's the reason why these guys are able to actually be on top of the water and kind of move along the water. Water will also cling to other polar surfaces. So this is great for these tree roots. Like if you think about redwood trees, because they're so big, right? They're so tall. And water, they can get a lot of their water from the ground, not all of their water from the ground, but we won't go into that. We'll learn that a little bit more when we talk about the ecosystem. But these redwood trees can absorb a lot of their waters from the ground. So how does water that's absorbed all the way here get all the way up to here? How does that water happen where, I'm going to put my little, pointer on, because I think that might be a little easier to see, right? How does water go from down here and somehow makes its way all the way up here, right? And it's because of the tension between the water and how it can actually cling. So they cling to each other, but they can also adhere to one another to kind of pull. My head is too big. I'm going to move it right here. So it can pull it all the way up. So another way to kind of see that is like when you suck on a straw, how all those water molecules can kind of bind together and actually be sucked up into the straw and into your mouth, right? So water is excellent for that because it does have that cohesion and adhesion characteristic to it. And it allows it to transport. So it's important because it allows us to be able to transport inside and outside really well. So we're constantly moving even within our system. Our water's in and out of our cells and stuff, and it's because of these different characteristics that kind of allows us to actually have our water be able to transport and carry the stuff that we need within our blood system to other parts of our body and so on. All right, so high heat capacity and heat evaporation. So this has to do with, just think how long it takes for water when you put it on in a kettle for it to actually boil, right? It has to absorb so much heat. Why? Because of, again, the hydrogen bond characteristic. In order for you to break that liquid state of matter, right? The liquid matter state of water to become gas, you have to absorb so much heat in order for it to get to that point where the bonds are kind of breaking and you can actually change the state of matter. So a lot of energy has to be added in order to actually get that to break. And you need enough energy so that the water molecules actually start moving a lot more. And so as it's moving a lot more, is able to then finally evaporate and go from liquid to water. And that same note, because once it's up, it actually takes a while for water to actually cool down compared to other type of compound. Water actually takes a while for its temperature actually decrease as well. So it takes a lot of energy to break that water bond for it to evaporate or vaporize, but it also takes a lot it also takes a lot of time and to get that water once it absorbs all the energy to actually come back down. So from water to go from liquid to ice. Right, so this is evaporation, this is the heat of vaporization. So a lot of energy is input for that water to break free. So like we use water, or not use water, but we lose water when we're like overheated. We have to maintain, and we'll talk about this a little bit when we talk about pH, about how in our system, we just have to maintain a very stable conditions. Like we don't like our temperature to vary much. We don't like our pH to vary much, and so on. So when we want to lower our body temperature, because like let's say you go for a run and you really increase your heat, one of the ways for us to actually lose some of that heat and bring our body temperature down is to actually lose water, because water carries so much energy with it. So when we lose some of that water, we're also like kind of losing some of that heat basically, so that we can actually lower our body temperature down. Okay, water also has varying density to it. So this is a very interesting characteristic of water, because when water freezes, like most other substances, when they freeze, they actually shrink and they actually condense down, right? But water, because of the hydrogen bonds, when it freezes, it actually expands. And so because it expands, it becomes less dense than a state of liquid. And so that's the reason why ice is able to float over liquid. And this is actually really important. Can you think of why it's important? Just think about a lake. So a lake has plants in it, it has animals, right? The fishes, all the different planktons, everything in there. And those fishes, in order for them to thrive and survive in that environment, the water has to be at a certain temperature, right? We hear about how as we get global warming, a lot of the species, because the water is rising, are having a hard time with that. Well, let's go back to a cold environment. So when winter comes, if ice didn't rise, then the freezing temperature that freezes water into ice would freeze that whole lake up, and all the animals and everything that live in there would die. So we actually need the ice to float, and when it floats, it actually results in this blanket that actually keeps the temperature underneath nice and stable. All right, so I hope this makes you appreciate water a little bit more.